Okay, so in this experiment, we're going to have a look at how to measure the energy change. So this isn't just about looking for the temperature change. This is about then using a formula to help us convert from a temperature change, which is obviously in degrees C, to an energy change, which is in joules. So this is the formula that we're going to be using here, and this is on your worksheet. So Q represents the heat energy change. M is the mass of solution. This triangle T means delta T, or a change in temperature. And C, this little symbol in here, is the specific heat capacity of the solution. Now, for all the experiments we do in chemistry, they are mostly water-based solutions. So we're going to use the mass of water that's in our solution as our value for M. So in a moment, I'm going to do this top experiment here with copper sulfate, and you can see from my table here that I'm going to be using 25 centimetres cubed of copper sulfate. So my value for M in this formula later is going to be 25. So 25 grams for the 25 centimetres cubed of liquid that I'm using. And later, when I do the citric acid experiment, you can see I'm using 25 centimetres cubed of solution again. So the formula that I use underneath to calculate the energy will have that same value, 25 for M. Okay. Now, although we're adding some solid to that, and that has a mass as well, we always ignore that because that's not part of the liquid that's being heated up. It will dissolve into the liquid, but essentially its mass is tiny compared to the mass of water, so we never include any mass of solid. It's only ever the water component or the solution component. Okay? So I'm going to need to record from this the initial temperature of my solution, the final temperature of my solution, and then I should be able to come back and calculate the temperature change, which I can then use for the value of delta T, triangle T, in this formula later on. Okay, so we'll put that to one side and we'll do the first experiment. So I've got the things set up here ready. This is 25 centimetres cubed, 25 millilitres of copper sulfate, and this is my zinc powder in this little whey boat here. I'm going to start off first of all by putting my copper sulfate solution into the polystyrene cup and take the temperature so I can get the initial temperature reading. Okay. I'm stirring my solution just to make sure that it's all the same temperature throughout. And I'm using a polystyrene cup because I want to make sure that if there's any heat change going on in my reaction, none of it gets transferred through the cup and into my fingers, or I lose some heat to the environment, or I gain some heat from the environment and mess it up. So by having a polystyrene cup, it insulates it against the heat exchange with the surroundings. I think I've given this long enough. I reckon that's on 20 degrees. I hope you agreed with me. I'm now going to add my zinc powder to this. I'm going to do it really quickly in one go and stir it up. And then keep stirring it so any temperature change in that liquid should be the same all the way through all the liquid that's in there. You can see the liquid's changed in the cup there. It looks very different now. And my temperature is changing as well. I want to try to record the maximum temperature that it gets to. At the moment, I think that's on 27. I'll look again in a minute and see if I think it's changed to anything else. You see if you can read it off the screen as well. I think it's crept up a little bit beyond there. I think it's on 28 degrees C. I hope you agree with me. I'm going to stop there and record my data in my table. Okay, so you can see I filled in the details on my table. I hope you've done the same. I'm now going to do this second experiment here using citric acid and sodium hydrogen carbonate. So I've got 25 millilitres of citric acid, which I'm going to pour into my polystyrene cup. I'll take the temperature of my citric acid. So I think my start temperature is 20 degrees C. I hope you agree with me. I've got quite a large quantity of sodium hydrogen carbonate that I'm going to add, so I'll try to do that nice and smoothly in one go and stir it up. You can see it's fizzing quite a lot. I'm stirring it well to make sure the temperature is evenly distributed through the whole solution. I can see the temperature is going down with this one. So I'm going to record the minimum temperature. Still fizzing in the cup there. Still reacting. Gosh, the temperature's gone down a lot. I think it's on about 3 degrees at the moment. Still fizzing away. Okay, pretty much stopped fizzing now. I actually think the temperature is on 2 degrees C. I don't know if you agree with me. You can see that on the screen. Two degrees is what I'm going to be recording in my data table. So I've now filled in the data from my second experiment. You can see that it's dropped 18 degrees C. So it started at 20 and went down to 2 degrees C. And I've been really careful to put the sign in there so I know which direction my temperature changed, whether it went up and I need a plus sign, or whether the temperature went down and therefore I need a minus sign. Now what I'd like you to do is to choose one of these sets of data that you're going to then use for the rest of the worksheet. So when it says here the reaction is something thermic, you're going to be referring to one or other of these. So you might like to put a little star beside whichever one you're using and then carry on doing your calculation and filling in the statements with reference to the particular experiment that you've decided you want to follow. Now your teacher may ask you to go back and do the same calculation with the other set of data, but I'll leave that for them to use.